So what is IXP Manager? Well, what we say is it's a full stack management system for IXPs. It's the components of IXP Manager, both an administrative interface as well as a member portal or customer portal for your end users. It's also an end-to-end provisioning system. We'll take a look at that in a little bit more detail than that. What we like to say is that IXP Manager teaches and implements best practice. So I've been at INEX for 7.5 years. Nick has been there for a lot longer. So we've been around IXPs for a long time, and we've seen, in my time, I've seen INEX grow from about 20 odd members to nearly 100 now, and gone from 2 points of presence to 6. So we've built up quite a bit of experience, and most of that is built into IXP Manager at this stage. And it's fully loaded with IXP-specific tools and features. I was going to talk in the other presentation about how we might start configuring switch ports and stuff in the near future, but for now, it configures everything but the port. So, why did we build IXP Manager? Well, some of the key requirements of an IXP are security, consistency, and reliability. So, we know we can't eradicate human error. It does happen, but the idea of IXP Manager is to try and take as much of the manual work out of running an IXP as possible. And what you'll see is, from 2 part-time engineers, I think between myself and Nick, we're a 1.2 full-time equivalent in terms of staffing. So neither of us work full-time at INEX. But we've managed to maintain an engineering staff of 2 and still grow to 80 members, 6 pods. And that wouldn't have been possible at IXP Manager. So it does automate an awful lot of what we do in the day-to-day stuff. So the kind of goals of where we're trying to get with IXP Manager is to try and find some way to get zero-touch provisioning and configuration. So as you'll see, we've a lot of that done. I think the only area we don't touch right now is actually logging into the switches to configure the ports automatically. That's somewhere we can get to really easily. Do more or less, as I just said, and also to provide excellent service to our members. So when a member opens a ticket, maybe they say, look, I haven't used a root service, but I want to use them now. For us, that's literally just logging into IXP Manager and checking a checkbox. And it'll spin out the configuration for the root service for that member automatically. This, by the way, is meant to be a workshop, so stop me at any time, ask any questions, make any comments, there's no problem there. So what's the history? I mean, the history of IXP Manager is pretty important to understand, especially if you start developing it. Because I know myself as a programmer that when you start looking at code, you kind of scratch your head and say, what the hell are these guys thinking when they did this? Well, when it comes to the same as, if you look under the hood of IXP Manager, you see a lot of intelligent stuff, but you'll see a lot of, what the fuck kind of stuff. What were they doing when they did this? And the reason is, it has been sort of an organic growth over 10 years. We didn't sit down 10 years ago and say, in 10 years' time, this is what we want. It just grew and grew and grew, and we added features to features. And sometimes we added features quickly to get the job done, rather than the right way. I'll take a longer period of time, if you know what I mean. So there is crud in there where we eradicate it when we can. But if you do look under the hood, you will see some little spider webs. One thing that hasn't really changed is the database schema. So Nick designed the schema probably 10 years ago at this stage. And it has remained pretty much consistent. We've added a few columns here and there, but in terms of how we've gone around representing customers and interfaces and VLAN ports and virtual interfaces and stuff like that, that hasn't changed. It's turned out to be a really robust schema. And that's, even from 10 years ago, that's where we started. And we started with a very simple CRUD, create, update, delete interface, just to add stuff in and out of the database. With a lot of scripts that ran around querying the database and throwing out different configurations. And we had a lot of provisioning scripts, mostly written in Perl, because Nick wrote most of them initially, that provision things like root collectors, root servers, AS1 and 2, reverse DNS, maintaining web objects, monitoring systems, graphing, and all that kind of stuff. When I joined in 2007, we undertook a project then to try and modernize this whole system. And this is kind of the beginning of IXP Manager as you know it today. So we put in a LAMP stack. Zen framework is the controller in that stack. Doctrine is the model, and Smarty is the view. Part of what we're doing for version 4 is we're changing Zen framework for something called Laravel, if anyone has any programming interest. And Smarty is a PHP templating engine that is awful, but there was no other choice at the time, and we're swapping that out for something else. And over the years, we continue to automate manual processes and thus grow IXP Manager's usefulness. An important thing happened in 2010, which is we ended up in a place where we said, this is actually kind of useful. It is very INEX-y, but it is also extremely useful. So we got the INEX committee, which is made up of the members of INEX, to approve open sourcing it. So in 2010, we opened it under GPL v2 and put it on GitHub. Now, there was no significant traction. It might feel to some of you that we've been talking about IXP Manager for years, but I guess the main traction has been the last 3 years rather than the last 6 years. And we found out that when you open source software, it requires a lot of effort. You need documentation, which we have none, which is pretty useless. It needs to be easy to install. It's gotten a lot easier. Some of you might say it's not particularly easy, but it's gotten a lot easier. You need to go out and evangelize it. You need to tell people that this thing exists and that it's useful. And we needed to de-INEXify it. So there was a lot of stuff in there, hard-coded things like INEX this and INEX that. And certainly in some of the ways and documentation within the system, there was a lot of INEX-y stuff going on. And then we needed time. We need to put some time in for kind of outreach, mailing lists, and just dealing with bugs and feature requests and stuff like that. So in 2012, we brought out version 3, and this time we put that effort in. We had a lot better documentation. If you look at GitHub now on the wiki section, there's probably about 40 or 50 pages of documentation on IXP Manager. We created mailing lists, we did UIX presentations, and we started going into some global collaboration with Jane Coffin and ISOC to push it out into newer IXPs around the world. This is quite old. I don't know what the current, Nick did a count there, and I think it's about 25 IXPs using IXP Manager at this stage. And for INEX, we've gotten great feedback, particularly for the committee who made the decision to allow us to put in the time and effort and resources in open sourcing it. We've gotten great recognition from it as well, which helps with underwrite their decision there. Let me just see where I'm going with this. Okay. So the main components of IXP Manager are, for INEX, we have it on 2 different servers. You don't have to do that. And eventually we might even collapse it into 1. Historically it's on 2 because we had servers that did 2 specific things. One we had for a web server for web interfaces, but most of the provisioning was done from another server. So all of the provisioning aspects of IXP Manager happened on one server, whereas the front end happened on another. The main criteria for wherever you deploy IXP Manager is it needs access to the management interfaces of your switches. So particularly needs SNMP access at the moment, but eventually you need SSH or some other form of ports for provision. There's a database at the back, MySQL here. I think in development I use MariaDB, which is a slot-in replacement. In theory, we use Doctrine, which is a database extraction layer built in. So in theory, it should work on most databases, but in practice it won't, because a lot of the scripts are hard-coded to MySQL. So MySQL is pretty much a hard requirement. And then off to the side, all of the ancillary services you build around your IXP, so things like root servers and root collectors, AS102, graphing, all that kind of stuff. It does need to exist in the IXP Manager server, but it will need to exist on a server somewhere. This is just a screenshot of the customer portal, the administrative portal. So what we're looking at here is the overview page of a particular customer, and the customer we've picked is the AS112 service, which is just in the system as a pro bono member. What you can see for this customer is you get stats. Ports will show. So ports will give you like the existing ports they have, the traffic stats, all that kind of stuff, and you drill down into it. Users are the users of the particular customer who are allowed to log into IXP Manager. They get a slightly different view, but it's who's allowed to log in. Contacts is just like CRM, maybe just marketing staff and stuff that we're keeping an eye on. And we'll have a look at the other stuff in a minute. To the left of this, you can see there's a number of options. These are all about managing the IXP. So customers for adding, removing customers. Interfaces is similar. Users contacts. We keep track of co-located equipment. We allow some of our members to stick some kit in their racks. Keep an eye on it here. The main stuff in terms of building the IXP, IXP Manager is very much IXP as a single IXP. So if you're running multiple IXPs in different parts of the country, it's not really suited for that. We did have some multi-IXP functionality, but the people who were sponsoring it moved a different way, and it hasn't continued. There are ways around it. I think we were discussing this in the mailing list. You could effectively set up multiple IXPs as multiple infrastructures. It's not the same, and it's not ideal, but it would probably work. Infrastructures are, at INEX we run 2 infrastructures, so we have a primary and secondary LAN, one running Extreme, one running Brocade. Same as Links, they have, I think they have a Juniper LAN and a Brocade LAN. That kind of thing where each LAN is completely separate to the other, so if one has a failure, the other keeps working. So that's your infrastructures, and locations are data centers effectively, so you just add your data centers, cabinets or racks, and then you add your switches. And when you add a switch, what IXP Manager will do is you put in an IP address and a community string, and it'll go and pull the switch over SNMP, find all the interfaces and all the other details, and throw all that into the database. IP addressing, just managing your peering addresses. MAC addresses right now is a read-only list of known MAC addresses on the peering platform. So there's a script in the background that will, through SNMP, find out what MAC addresses are known on the switch and to what port they're learned from. So if we see errors and packets, we can quickly identify where it would come from. But more importantly, we use it for the peer-to-peer graphs for SLO, so we know who owns what port when we get the SLO packets in. Vendors are just a kind of static list of switch vendors. Console server connections is kind of important. We stick a console server in every POP for connecting to our own switches for out-of-band access, but also for customer devices. So that just has a mapping of what port each switch is connected to on the console server. VLANs, we run obviously a peering VLAN. We've ran historically 2 more, a VoIP and a Jumbo packet. Neither have gained any traction. I think they don't even exist anymore. We also have a quarantine VLAN. IORDB configurations, but adding in routing registries. So you can, for the root servers and static prefix lists or prefix lists for routes we're learning from members in the root servers, that we can automatically generate all those lists. And then there's just a couple of tools at the end. All of the members' graphs. We have a league table. We kind of keep track. From the graphing, we can see how much traffic each member pushes through the exchange. We can build up a league table to see who the biggest guys are. This is how we edit and manage ports belonging to members. All right, this gives you good insight into the schema that we have in the database. So for BT Ireland, you can see that for this particular virtual interface, so every interface kicks off with it as a virtual interface, and to that virtual interface we add physical interfaces. So you can see BT Ireland has two 10 gig ports on this particular switch and these particular ports. What happens is when you add more than one physical interface to a virtual interface, you're obviously creating a lag. So, and IXP Manager is aware of that. If there's one interface, it's just a standard port. If there's more than one, you've got a lag. And then to the virtual interface as well, then we add the layer 3 information, so the VLAN interface. So here you can see that BT Ireland has access to the peering VLAN. So on VLAN ID 10, that's their V4 and V6 address. Some other features of IXP Manager are that it allows for private VLANs between members. So if, for example, BT Ireland had a private VLAN with ABC Limited, you could add another VLAN interface here and stick in that private VLAN, and that would come up here as well. And when they log in, they'll see that same information too. This is what the members see when they log in. This is what happens for the admin when you click the ports. So again, you can see kind of the same information, it's just summarized better. Connection 1 is on infrastructure 1, switch speed, what location it's in. There's new information that we've added to this as well, for example, media type. That's a code off of the switch, so it's an SMF optic or a CUSFP, or it's just a standard copper interface. You can see that this particular member has no V6 enabled, but they have V4. You can see that they are on the root servers, and you can see that they're not an AS112 client. So for your own members, your own customers, what's available to them if you set up IXP Manager is they get their traffic graphs. So for each port they'll get their bits per second, packets per second, errors and discards. And then for peer-to-peer graphs, they'll be able to see what traffic they do with each other member of the exchange. Each individual user from any of your members can log in and subscribe to different mailing lists. So we have a members mailing list for general discussion, we have a tech mailing list, and we have other mailing lists. They can update all their not peering contact details. Peering Manager is a very nice tool that we have. As part of the SLO export that we take off of the switches for calculating peer-to-peer graphs, we also try and see if any of those packets are established TCP packets on port 179. Okay, so if they're established TCP packets, an established session, we can say, right, these guys have a bilateral peering session between each other. We build that up into the database. So when you log in as a customer and you click on Peering Manager, IXP Manager will work out whether you're on the root or not, and based on what bilateral peering sessions you've detected or not, who you don't peer with. And then it will show you if they have an open policy or selective policy, and it'll allow you to initiate a peering request directly within the system. So it very easily shows you who, at our best educated guess, who you don't have a peering session with. Peering matrices is built up from that same information, so using the root server membership table and the bilateral sessions table, we build up a peering matrix. As a member of the exchange, you can see your fellow members' details. So you can get their NOC contact details, their peering contact details, all that kind of stuff. What switches they're on, what ports they have, what information is available from one member to other members, if you know what I mean. We have some of our own documentation within there that, IXP Manager is skinnable, so you can add your own pages and stuff to that. It's not a CMS. You can add pages in the back end and get your own documentation on. They can manage their own users. It's very much like the old RIPE system, where there's an admin account that is just used for adding the leading users. That'll change. What we do is just treat that as a user. There's admin, customer, admin, and customer. Customer admin will become a read-write user effectively, and a customer user will become a read-only, is the plan. And admin will stay obviously as admin. And then the root server prefix analysis tool, I think we'll deal with that a little bit later here as well. So actually, this is the peering manager which I was just talking about. So for whomever this member is, you can see that it's telling them that they don't have a session on V4 with Tree Ireland on peering nav 1. Same for Interfusion, that they don't have any peering for V4 in either of those networks. I think this was probably AS112, so there's no V6 information on this. But it splits it out between V4 and V6, whether you have a peering session or not as well. And there's a button there to write request peering. It'll pop up a pre-formatted email that will be sent to the peering contacts of whomever you're button against, with a fully formatted email including their details and your details. You can edit that a little bit as well. So I think we're going to dive into a little bit of the features in a little bit more detail. Any questions or comments on any of the other stuff there?
Can you measure the IXP management? Can you manage the IXP management?
The IP addressing? Yes. Yeah, that's there in the menu.
I saw the IP addresses.
Yeah, so when you click on that, it breaks it into V4 and V6. You can add ranges and assign those ranges to a particular peering map. So that's
You just say the peering map, but not the management.
Oh, the management, no. So it's not an IP address management system, it just cares about the addresses for peering. Yeah.
Excuse me?
Yeah.
About the traffic graphs,
Yeah.
you said each member can see his port and capacity, etc. Can he see the other?
No. Just, you can see the traffic that he specifically does with the other members. So the peer-to-peer stuff. Not like, you said you're from NetNode.
No, they would like.
So the guys in NetNode, I think, do that, but no. There's not actually the facility in IXP Manager to let that happen. You'd have to go in and have to code. So it only allows you to see your own graphs and the traffic you do with any other member. Admins can log in and see everything.
I've seen that you also can add racks and switches, so assuming you can put a switch in a rack and all that stuff. And do you also have like connections between switches and to patch panels, etc.?
Yes.
No. That's actually in my other process we're going to do. Patch panel management for data center cross connects. We've been working on that for 7 years. We've been working on implementing it for 7 years. We have at INEX, I'd say we have between 25 and 30 patch panels. We manage them in a wiki right now, and it's painful. We went to add it to IXP Manager about 3 different times, and it became complete bike shedding. We completely overtold it every single time, and we said, it's too much effort. What we should have done is just implement the equivalent of the wiki in IXP Manager. So just a simple table with patch panels and maybe optional links to switch ports or customer kit, and leave it there. And then if we wanted to add lots of more cool stuff like graphing and all that kind of stuff, we can do that later. So if we don't overthink it, we can do it very quickly.
You showed the MAC address management thingy. Is this read-only, as you mentioned, or
It's read
can you, so the customer is not able to change the MAC
No,
address
so
on maintenance?
at INEX we do static layer 2 ACLs, but it's not managed in IXP Manager at the moment. LunApp are doing dynamic port security, and they're screaming at us to, in a nice way, to implement layer 2 static ACLs, and it's top of our development list. So it will be, we will allow, we will have IXP Manager manage their static layer 2 ACLs in a switch agnostic way. And what we normally do is we normally do a reference implementation for whatever kit we're using. So that would be for Extreme and Brocade as it is. And we will allow customers to go in and add a Mac to that so that they can make equipment changes in the middle of the night without having to ring us at 2 a.m.
And another question, is IXP Manager already aware of carrier programs,
Reseller.
reseller
Yes.
models? Yeah.
So it supports the fan-out model, if you know what I mean by that. So you get your big reseller trunk into one port, and then you literally for each customer reseller has you patch into the switch. Like that works really, really well, but it doesn't scale very well. It will work for P tags, which is you get one big trunk in. The reseller says we're going to bring them in on VLAN 3071, and you just map that into VLAN 10 through a virtual interface on the switch. We do have that at INEX, but it isn't implemented in IXP Manager yet, and there's a little bit of work we need to do. So the 3 questions that we asked so far are the 3 things that are top of our development list.
Brian, do you have somewhere published what is on your to-do list or what is your priorities?
do. My other presentation.
So we should hold off.
Yeah, we keep going. Okay. So we'll see. I forget how much detail this is, so we'll just see what's in it. MRTG configuration. I suppose I should say from the outset that IXP Manager right now, if you want to do graphing, you have to do it in MRTG using log files. Okay? To solve the problem of reseller ports with P tags, we need to have graphing with SLO. But we also have some people asking us for MRTG with ORD files, for example. What Laravel 4 allows, well, it's not Laravel 4 specific, it's a much easier base to work off. But what we're going to do for a number of different things, and I have a very clear example in the other presentation, which is about help desk integration, where we've integrated with Zendesk, but we've done it by programming to a contractor interface. So if anybody needs to integrate with your other help desk, they just have to look at the interface, fill in the functions from the interface, and it will just work. So we're going to do the same with MRTG, and DKIX have actually offered us a bounty to get that work done. So we'll augment IXP Manager so it's back-end agnostic in terms of the graphic system that you want to use, but the reference implementations, the ones we've actually developed, will be MRTG with log files, MRTG with ORD files, and SLO. And the SLO backend will probably be OpenTSDB, which is time series database, or if Will convinces me from LunApp, it'll be Whisper, the database behind Graphite. So in terms of graphing, what we graph is individual port graphs. So as I said earlier, bits, packets, errors, and discards. We also, anyone who has a live or an aggregate port, we add those together. It's all done through MRTG. Then we have the overall graphs for a particular member, so you can see the entirety of the traffic is doing over the exchange. We graph all traffic on each individual switch. We look at the inter-switch trunk graphs, so how much we're doing in terms of our core network. Aggregate infrastructure, so all the traffic on LAN 1 and all the traffic on LAN 2, and then the overall peering graphs. The nice thing about MRTG for this is that once it reads in a particular run, when it reads the interface's stats of a particular interface, it just does it once. So it's not doing it 5 times for each version of this. There's an asterisk here because this is currently manually configured. So if you want to do your inter-switch trunk graphs, you have to actually go and just edit one config file to add them in. So the configuration is completely automated, and it's really well documented actually. And once IXP Manager is up and running and you've added your switches and you're adding members and you're assigning ports to members, I mean, you know, it really is an apt-get install MRTG, make a directory for members, and then you set a couple of options in the config file, and then you just call a particular command, and you do that. You do that anytime you change the configuration, anytime you change the port or something. So you just basically prompt a cron job to run every couple of hours or twice a day or whatever, and MRTG is done. So automated provisioning. So this is where I say we can figure out about the switch port. So when you add an interface to IXP Manager, what falls out of it is you get the root collector BGP session. So at the moment we're running a small Cisco iOS, I think it's 1800 series device as a root collector. As you know, root collector just collects roots, doesn't do any transit, doesn't advertise roots. It's just used for debugging and all that kind of stuff. And the way that's done is just pushed out through Rancid to the Cisco device itself, just a particular snippet. There's a slight problem with that in that we don't have anything that will undo a config. So if we delete an interface, there's nothing that will go in and get rid of that. That'll be solved through some of the things that Laravel can do for us. But at INEX, we're also probably going to get rid of, we don't need to run Cisco iOS device in our root collectors, we're probably just going to switch out to Bird. Nice thing with Bird is you just generate one file, you reload it, and you don't need to worry about it. You don't need to worry about keeping track of any interfaces that you've deleted, because you just refresh the config. The root servers are also auto provisioned, and I think I have a lot more detail about that in a minute, so I'm going to skip over that. MRTGs we just talked about. The peer-to-peer graphs are also auto provisioned, and that's done really easily. Once the new member starts trafficking, his MAC address will get known on the switch. The script that learns the MAC addresses to fill that table will learn his new MAC address. And then the script that takes all the SLO packets and says, right, A is talking to B, who's A and who's B, that will refresh the database every couple of minutes, and it'll just start building up the ORD files. We monitor all of the members' interfaces unless they ask us not to. So we just send a few pings every 5 minutes on Nagios. Particularly, that's really useful for things like pre and post maintenance. So before you do maintenance, who's down already? And then after maintenance, I hope the same people are down, but no one else is. Smoke ping, we also use smoke ping to ping all the member interfaces unless they ask us not to. As you know from smoke ping, those graphs can often look really crap, like lots of packet loss when you're pinging a router interface, which doesn't indicate an issue at the exchange, it's just how routers handle ICMPs directed at themselves. Now, what we look for there is a big differential. So, has something changed? That might indicate a problem. AS112 is, if you've asked for the AS112 service, that session is pre-configured automatically. In the interface, when you add a VLAN interface, you put in the reverse DNS, whatever they want it to be, that's configured, and then all of the, we have AS sets for exchange members and for root server members, and they're all just automatically built up and set up to run as part of the whole process. So yeah, I said I had more root servers, which, as we know, are critical infrastructure. I think in general, members care about the switches and they care about the root server. If the root collector goes down, they don't really care. If AS112 goes down, they don't care. If IXP Manager goes down, they don't particularly care. If there's a problem with the exchange or problem with the root server, they care a lot. So they must be secure, robust, free from operator error. When Nick first built the root servers, they were auto provisioned from day one, so there was never anything manual about how we configure root servers. Yeah, so I'm just saying, IXP Manager contains INEX's broad experience here. I mean, Nick has been in root servers. He's ordered RFCs on this, I think, or a draft going through IETF. So our templates, in terms of securing them, we have match prefix restrictions. We have the 4 and v6 Martians, all part of the templates. And our templates, by the way, are all on GitHub. Right? So we may skin them specifically at INEX, but the base ones that we work off are all on GitHub. So we do strict inbound prefix filtering, and the way we do that is We use, I don't know, have any of you seen this BGPQ3 tool? Really, really useful. You just get your command line BGPQ3 AS, whatever number, it will give you all the root objects that are known in RADB. You can specify particular routing registries as well. So it's a really useful tool. For programming with it, it gives JSON output as well, which is really handy. So the script that we have to build up a database of our member prefixes that they should be allowed to advertise to a root server. When that runs for each AS set, it'll run BGPQ3, get all the v4, v6. It'll stick it in the database. And it will query RADB particular sources. So for us in Dublin, most of our sources are right. But we may have Google or something that says, no, don't use right, use some other source. So we use whatever we're told to use. And we can also query multiple source databases. So a member might say, look, you need to query here, here, and here for our prefixes. And that's fine too. In the past, the building up these prefixes and configuring root servers used to be a sequential process. So it would take maybe 45 minutes to an hour when we had about 60 members to actually build up a root server configuration. What we've done now is we split that in two. So there's a process that will feed our own local database a list of all the prefixes. And that's what that's. So if a script that needs to create the root server configuration happens around at the same time, it doesn't matter. It's transactional, so we'll get whatever view, the pre or post view of those prefixes. So now we can spit out a bird root server configuration in about 3 seconds, which is great when we have new members who are joining and says, yeah, we want to use the root server. Done. It's very good. We also do next hop hijacking prevention as part of the default scheme. And we support the standard communities. And this is all in that bird configuration file that's part of IXP Manager. It's in GitHub. So that all that detail is there. And it's all very well documented as well on the wiki. Yeah, Quag and Bird are currently implemented. If you were using Cisco, for example, it would be very easy to take the Quag template and adjust it. I think most people have settled on Bird, but Quagga and Cisco, I think, are still quite popular. Just skip through this. So this was the other thing I skipped earlier. So the problem is with a root server, when you start using strict prefix filtering, you start getting a lot of queries from your members saying, I have a new prefix, are you allowing it? Or I have a new prefix, I don't think you're accepting it. Well, we have a tool, a script that runs on your root servers, and it actually goes and learns using all the sources of information it has. So it knows all the prefixes you should be allowed to advertise. It knows the prefixes you are advertising, and it knows the prefixes that you're advertising are getting blocked. And thus it also knows the prefixes that you're not advertising, but that we would accept. So each member gets this tool that they can see in IXP Manager. What it shows them is, the first one is the warning one. It's advertised, prefixes you're advertising, but we're not accepting. And invariably that means a root object doesn't exist in the routing registry for that prefix. You have the list of advertised and accepted, and then you have the ones that aren't advertised, but if you did, we would accept them. So the last one is also quite useful for some members who might be doing larger ISPs that might be doing community filtering and stuff within their own network. That they might, we need to have those routes aligned as whatever as well. Any questions on that stuff? I hope I'm not going too fast, but equally I hope you can see that, if you actually go and install IXP Manager and use it, you get a lot of stuff straight away. You get all this graphing will just work, root server configuration just works. And all this stuff is very well documented. Peer-to-peer graphs. This was actually, a lot of people who are using IXP Manager haven't done this. All right, so it's an extra step up to get this running because you need to configure things like S-flow exporting off your switch, you need to get S-flow handlers running on servers. It's an order n squared problem because you need, for n members, you need n squared files just for packets, and then you need it again for bits and stuff like that. So it requires a lot of disk I/O as well. So it's something that needs to be planned. But when we did implement it, member logins in IXP Manager would look about fivefold. We now have members coming back and logging in every other day to see what kind of traffic they're doing to Google or Netflix or whoever they're interested in. Yeah, so the current information, I mean, you know, whatever, it's SFlow really, because what we need is the MAC addresses. I think NetFlow v9 might support that, but our implementation is NetFlow. And you can see the source and destination MAC address comes in that SFlow packet, which is what we need to know who's talking to who, what protocol it is, and then we have the packet size times the sample rate to kind of get an idea of how many bits per second we're talking about. Yeah.
The next one is your billing matrix. The way that you implement your billing matrix is not based on this information, right?
Well, one of the things that we learned from SFlow is who has an established BGP session. So who's talking to who on TCP port 179. So it's not a SYN or a SYNAC packet, it's an actually established packet. And that allows us to decide who has bilateral BGP sessions. So it is SFlow data, but it's the same. What happens is all the switches export SFlow data to a particular SFlow server, and that server takes that SFlow data and just spans it into 2 or 3 different processes. So one process is this one that does the peer-to-peer graphing. Another process is the one that looks for established TCP sessions, BGP sessions.
So the billing matrix actually looks for BGP session and not just traffic that is being exchanged.
It actually looks for BGP sessions. It was implemented before we had the peer-to-peer graphing, although I think we'd still probably look for established TCP sessions. Yeah, as I said, we have a number of live objects which are all automatically generated. I don't think we need to go into that. Maybe we take a 5-minute break, and anyone who wants to, we can look at the second presentation on version 4. All of this there is help desk integration for different reasons, and that's actually very done. Layer 2 ACLs was mentioned, reseller ports were mentioned, pass panel management was mentioned, and I was talking about intelligent provisioning. And then the only other thing I don't think we mentioned was advancing the peer-to-peer functionality. Actually, that did come up a little bit.
What is the help desk integration? What do you mean by
Help desk, I'll talk about it in a second. So something like Zendesk, for example. So managing customer issues. So in terms of the layer 2 ACLs, what we're looking at here is basically putting this functionality into IXP Manager, as we discussed, so that members will be able to go in and log in or change their ACLs themselves. And the usual constraints exist. Well, however we do this, it has to be secure. It needs to be switch vendor agnostic. And again, as I say, what we do is we develop for the switches we have, which will mean Extreme, and it will mean Brocade. And then it'll need some knobs and dials. So for example, if 1 or 2 IXPs are saying, maybe you should allow more than 2 ACLs or 2 MAC addresses rather. So when you're changing, you should have more than 1 MAC address, maybe you should have 3. I'm not sure there's a real reason for that. But also things like expiring MAC addresses. So if you want to add a MAC address because you're doing maintenance tonight, when should we expire the old one? Because we also want to rely on members logging in and taking stuff out themselves either. So just a few kind of knobs and dials. The peer-to-peer stuff, as I said, it's currently via ORDs, and this in particular limits feature development. So we have no way of querying, like unless you go through each ORD as a script and sticks some data in a database, there's no real way of querying across n-squared ORD files to try and get maybe the top 10 tokens for a particular member and stuff like that. So one of the main problems in IXP Manager is that when a member goes in to look at peer-to-peer graphs, they now get a page that just shows them 80 graphs, so one for each other member in INEX. At LUNAT that would be 160. That takes quite a while to load and generate. Ideally we show them their top 10 or their bottom 10 and let them search for any other ones they like. But in order to find the top 10, we need a database to query that stuff. So we were looking between OpenTSDB and Graphite Carbon Whisper. OpenTSDB has some really cool features, except it's incredibly complex. In fact, I think I pretty much decided last week that it's so complex even just install it, that's probably not worth the effort. I think it's too much of a barrier. I think probably Graphite Carbon Whisper is a better way to go here. Yeah.
Did you have a look at InfoxDB?
Yeah, it seems to be a little bit behind OpenTSDB.
Yeah, it's somewhere in between the two, I think.
Yeah. My only thing I'm not in love with Whisper is, again, it's a fixed size database. You know, I don't know if we care what you were doing a year ago. As in, I don't care if the member cares what they were doing a year ago. I think that's the only constraint on Whisper. You know, we haven't made any decisions yet. We have to have a better look at them properly. And the other thing we need to look at is how easy it is to implement Influx or Whisper, but also how easy it is to send data to them and how easy it is to query them. And then as well, this kind of, ideally whatever we choose would work on a server, not like OpenTSDB is distributed on loads of servers, but you know, that's getting into bigger territory for than we need. So that's the advancing P2P stuff that we're looking at. The other thing that came up was reseller ports via PTAG, and as I said, IC Manager stance fully supports the FANET model, which is kind of the smaller scale way of doing reseller ports. Our new kit, the Extreme kit we have, allows PTAG, so we now have people using PTAG, resale members on PTAGs. Unfortunately, it breaks a lot of things. Port traffic graphs by MRTG SMP don't work anymore because there is no physical port. The MAC address learning doesn't work because there's more than one member on a port, so we don't know who owns the MAC address. So that screws up peer-to-peer graphs. So right now we have two members where we have no visibility. So this is a problem that we're working on fixing. And the reason it's layered like this, two ACLs, advancing peer-to-peer functionality, and then reseller ports, is because layer 2 ACLs will fix the dynamic ACL problem, and advancing the P2P for SLO collection should fix all the graphing stuff. So yeah, there's a certain structure to those lists. Pass panel management, I think we covered all of this. Intelligent provisioning. So it's an often requested feature, even internally at INEX. You know, there's two main tasks that we do. One is onboarding new members, and the other is provisioning new ports. But you know, we still use a Word document for joining an exchange, and that's just yuck at this stage. You know, it falls on me and Nick to do all the technical validation, which in reality we could automate if there was just a web form. But the reason we haven't developed a web form is because we want to do this kind of intelligently, and not every IXP is going to use the same, look for the same data that INEX uses or query ports in the same way that INEX does. So we want to try and build an intelligent, configurable, scriptable provisioning system that any IXP who's IXP Manager can kind of bend and twist into what they need it to do. So provisioning a port at INEX kind of looks like this. It's a really manual process. A member new or a member requesting a new port asks for a port via the Build IXP Manager. We create the virtual interface, and then we create the physical interface. We assign a free port. We then go to the wiki and find the patch panel port. So again, the ordering earlier on is important. Intelligent provisioning falls underneath patch panel management. We configure the port in quarantine. We confirm the cross-connections in place and record the data center's ID. We test the port, ensure speed duplexes are matched. We quarantine the port, which means we check for spam, trees, discovery protocols, all that kind of stuff that we shouldn't see on the exchange. When in quarantine, we have a root collector that's configured exactly the same as a production root collector, same IP address, same MAC address even. So we get them to peer at that in the quarantine process. We check what they advertise, and then when we flip them onto the production LAN, that session just reestablishes with the production root collector. So we put the port live in the production peering LAN, we set up the root collector, root server AS102 sessions, and we send announcements. Now, I mean, like, okay, that's automated already. In fact, they're kind of automated already. Now, we could automate pretty much everything else. A lot of the switch stuff could be automated. And the only thing I haven't, could we automate the quarantine port? I don't know if we could, but we could certainly make it easier. We could certainly have the TCP dump server set up a session automatically, email a PCAP. We could make it easier. Rather than the very manual process of logging to a switch, setting up a mirror, then recording all that traffic, and then trying to go through it later. We could make that a lot easier. So how do we design a provisioning system that will work for every IXP, not just INEX? Well, I think when you look at each step, in any provisioning system or any process system, there's a lot of common steps. So it's whether a particular action is pending on the customer or on the IXP. So who are we waiting for here? It tests to determine if the step is complete correctly or incorrectly. For a cross-connect going in, that could be a port coming up, for example. An action to take in completion. So if the system sees a port come up, right, we move on to the next step in the provisioning system. Messaging, so emailing customers, emailing mailing lists to say new port is live, that kind of stuff. So all of this, when you look at that and then you think about, your typical object-oriented programming stuff, you can kind of see it's quite easy here to try and build up some form of process that is made up of steps against a contract where you just fill in certain functions for each particular step. So what to do when the step is started, what the action step has to take, what to do when it completes, and then moving on to the next step. So I think we can do that in a way that will work for most people, but not without a little program. So just then on port configuration templates. Standardized port configurations on IXP are obviously essential. At INEX we did a forklift upgrade from Brocade to Extreme on LAN 1 over the last 12 months or so. As part of that, we used IXP Manager to configure all the ports on the new switches. It's time efficient, there's no operator errors, we ensured all configs were standard, we ensured that no elements were missing, that the layer 2 ACLs are in place, all that kind of stuff. Now we did this in a very hacky way, which is why it isn't in IXP Manager. We just need to get a job done, we didn't have time to make it look nice. It could be easily integrated, even without the provisioning process. You should be able to look at any port in IXP Manager and just say, give me a config for that. And this IXP Manager could say, right, this port is live, it's in quarantine, it's on an Extreme box, so here's your config. And that config should really be shut down the port, reset to defaults, stick in the new config, and bring it back up again. And when you build in that kind of logic into IXP Manager, well, then you create new tools here. It would also be good to use, if you back into configs with rancid or oxidized, it'd be great to be able to pull those scripts to make sure you're not missing any elements of the port config. Maybe you're missing a broadcast storm or layer 2 ACL or anything like that. So that should all be possible with that kind of those kind of tools. So V4. So major version changes usually mean major changes. For us, what they meant between V1, V2, V2, V3, V3, V4 is framework changes. So it's basically changing some major component of the framework. And in this case, we're changing both the controller and the view. So version 2 to version 3 was changing the model, going from Doctrine 1.2 to Doctrine 3, Doctrine 1.2 to Doctrine 2, which was really a huge change because it was, in terms of database, it was going from an active record system to an object relational mapping system. So that anyone's name. Anyone program? Script? A little bit. Won't go into too much detail then. But just when I'm talking about Doctrine and what it does, it's useful to put it in context. So in terms of coding IXP Manager, creating a customer is pretty much creating some new customer object, setting various values, and then persisting it to the database. Right? And this is Doctrine. This is what Doctrine gives us. You can see there's no MySQL insert or any of that kind of stuff. It's just database abstraction. It's the object is the entity, and creating a customer is just that easy. Finding all the customers looks like this. Some customer repository. So we get a customer repository, and then we basically find all customers. Then we can iterate over them and do something. Doctrine has been stable. It's been around since 2006, so it's quite an old project, and it's a number of libraries stacked together. But the two main important ones are DBAL, the database extraction layer, and then the object relational mapping. Just the concepts. Entities represent a single database row, so that was that customer entity we just created. Proxies we never really need to deal with them programmatically, but whenever you talk about doctrine, you talk about three different things. You talk about entities, proxies, and repositories. The proxy is basically a compiled entity. Doctrine does it in the background. And what it does is it allows for lazy loading. So if I load a customer, and I want to say, customer, get virtual interfaces, well, the proxy will go off the database to find all the virtual interfaces. If I only load up three columns of a 20-column table, the proxy will load up the extra columns if I go looking for them. And then the repositories handles sets of entities. So most of our complex queries in IXP Manager are handled by the way of repositories. So here's the customer repository, and you can see we have a function here that we use all the time, get current active. So this function gets us all the current active customers from the database. And if you want to get it as an array as opposed to entities, if we only want the ones that are trafficking, so not associate numbers, for example. External only means not INEX or not the root service because they exist as customers for the provisioning system. So if you look in if you're going through the code base and you look into the database repositories directory, you see a repository for each table in the database where all these utility functions exist. And the great thing about these utility functions is they actually help explain an awful lot about how our schema works. Okay, so when you look at the big schema and the 30 tables, you might kind of scratch your head and say, how does a virtual interface relate to a VLAN interface and to a VLAN and IP address? You find a lot of that detail in the queries and how they're built up in the repository tables. So the view in the model view controller, well, the view separates logic from presentation. That's its main purpose. In large projects where you have lots of developers and people who work in UI, it means that the UI guys never need to look at the code base. Just you have all these templates and you get a little bit of data to fill in the gaps. It eradicates this horrible thing in the early days of PHP why it has a bad rep of spaghetti code. It allows templating with layouts. So if you look at IXP Manager, you'll see you've got the menu at the top, you've got the left-hand side menu, and then you've got the main content area. That's all just a layout. So the top and the left are all taking a particular file, and then the content will be rejected. And if any of you using IXP Manager, you may have skinned it, you may have added your own content or changed certain pages. Well, the templating allows for that as well. For years in a game in town, PHP was Smarty, and it is god awful. But it's of its time. It's 10, 15 years old now. It's not object oriented. It's really crappy stuff. So the contenders today are Twig, which is kind of really nice. Blade, which is actually built in one on Laravel. But the problem with any templating system, as I've learned, because you mightn't do any of it, but if once you go back, you scratch your head and say, what was the syntax for doing a certain thing in Smarty? The problem is it's more overhead, so you've got more syntax, more libraries and functions to learn and all that kind of stuff. So there's a new game in town for PHP called Plates, and it's actually it's native PHP templates. So if you learn PHP, you know the templating language. It's all the same PHP functions, same syntax for looping and for if statements and all that kind of stuff. It's inspired by Twig, so it gets a lot of how it does layouts and inheritance from Twig. It's easy to extend. The important thing is that it's a template system. Okay? It's not spaghetti code. Just because you're doing it in PHP doesn't mean that it's spaghetti code. It's completely separate to the backend. So again, it runs it in sort of its own container, and it just gets the information that you tell it it can have. In reality, version 4 will support Smarty, Blade, and Blades out of the box. It's just the way the framework works. The controller, it's the biggest part of the MVC. It routes all the requests, it takes care of all the middleware, input validation, all the responses. The new controller that we have is Laravel, so it's not just a controller, it's a whole framework. So what I mean by a framework is it gives us all these new tools we can use. So events, queues, task scheduling, testing, migrations, packet management. So, why did we change from Zen Framework to Laravel? Well, we were using Zen Framework 1, and that was end of life about 2 years ago. And it's been around for about 10 years. The next step up from Zen Framework 1 was Zen Framework 2. It was a complete paradigm shift. There is no upgrade path, it really is a recode path. So we had an option then to look around and see what other frameworks are around. The hottest thing right now is Laravel for lots of reasons. There's Symfony and there's a few other ones as well, but Laravel is definitely the hottest one. And when you try them out, Laravel actually is really, really good. We could have kept going in Zen Framework 1, just because it's end of life doesn't mean we have to stop using it. But the problem is, you get developer apathy, right? So even I get bored of this. I'm saying, like, I have to develop new features. If I had something else like Laravel, I could do this really, really easily and really neatly. But I can't do this using this, 8, 9, 10-year-old technology. So this is the real reason why we changed the framework, is to try and keep up with modern programming techniques. Now, when you change the framework, we can't just throw away the existing code base. There is 7 years of work in IXP Manager, and we're not going to lock ourselves in a room for 6 to 12 months to recode all that in Laravel. That just doesn't make sense. So over the course of V4's lifetime, the plan is to migrate from Zen to Laravel. Maybe completely, maybe not completely. Maybe we'll keep a little bit of Zen in the background. But the main thing is that Zen and Smarty will coexist with Laravel in place for quite some time. What it means is that all the new stuff we're talking about, we can just go ahead and implement in Laravel without having to worry about migrating all the old stuff. Remember, Doctrine isn't changing. Doctrine is still there in the middle. That's the database, the integration of the database, which is really where all the intelligence of IXP Manager is. So how do we keep both? Well, depending on, there's not a lot of programmers, so I'm going to say it's an elegant solution. If there were programmers here, you might argue and say it was inelegant. But what happens is, on IXP Manager v4, which is live at INEX, when a request comes into the web server, Laravel 4 handles it. Laravel handles it. If Laravel says, I don't know what this request is, I don't have a root for it, this doesn't exist here, it throws a 404 exception. And in a particular file, we now catch that 404 exception. We just pass the request off to Zen Framework. And Zen will handle it if it can, and if it can't, it will throw a 404 that'll just say we don't know what page this is. So it just funnels in, goes into Laravel, and then if it needs to, it falls back down into Zen. And it doesn't exist there, it just sends out a 404. It looks like this in the code. So Laravel tries to process it, throws out a not found exception if it can't, and then we just spin up Zen. It surprisingly adds hardly no overhead to the request. So more reasons for Laravel 4 is events and queues. So events provide a simple observer implementation. So code I write or code you write as an extension to IXP Manager can subscribe and listen to certain events. And then these events can be fired when something significant, whatever we define as significant, happens. And the nice thing about events is that they can be shunted to a queue for offline processing. So maybe as part of an event you need to send an email. In modern web programming, we don't do that in sequence with the web request. We stick that on a queue and just give a response to the user much quicker. So Laravel supports Beanstalk, and the other one that supports is synchronous. So when you're developing, you do synchronous, which means events are processed immediately as part of the request, but otherwise you stick it on Beanstalk and then the process are handled in the background. So with queues and events, what can we do with this? Well, this is where we get into kind of interesting stuff in terms of provisioning. Let's say I go onto the IXP Manager and I change the physical interface in some way. I change the port, I change the speed. Something we do every day, and then we just go do a lot of manual tasks. But what I can do now is I can fire some event, like a physical interface changed event, with the old and the new data. And I can have a number of listeners in the background. So for example, I can have an MRTG listener, and that can check to see if the port speed changed, or if the port changed. And if it did, it can regenerate the MRTG configuration immediately. There's no need to wait for a cron job to kick off an MRTG reconfig. That happens maybe twice a day. The end user will see his graphs almost no gap, because it will just happen in the background. We can send billing notifications to accounts. And as multiple ISPs using this stuff, you can enable or disable these handlers. I'm not interested in billing notifications. disable that handler, or I want to do a lot more with this billing. I want to integrate with our Sage CRM system or invoicing system, and I want to throw up an invoice out of this. You can handle that out of a physical interface changed. The switch configuration system could roll out configuration change for the switch. That in turn could fire a new event. So, and a physical interface status system can say, right, port has changed here. Does everything match up? Port speed, duplex, are all those correct as per the configuration? Similar things, VLAN interface is kind of the core of our stuff. So if we change something there, rather than waiting on cron to kick off configuration changes to AS1 and 2 root vectors, root servers, we can do all that on the fly almost immediately. Throw it on the event queue, let some event processor go through it immediately and make all those changes. Same for slow ping Nagios. All that can be done immediately rather than once a day. Not a lot of people put up their hands when I said any programmers, so I'm just going to skip some stuff. I think the important thing about how we're now developing IXP Manager is we're trying to be very less INEX centered. INEX aren't giving people who use IXP Manager, there's 25 other IXPs and hopefully a lot more. So just because INEX decides to use Zendesk as a help desk provider doesn't mean everybody else will. Just because INEX decides to use a particular implementation for BGP daemon doesn't mean everybody else will. So we recently had to do help desk stuff. So from a members presentation a couple of months back, these slides are from that. So up till 2008 we had a shared IMAP mailbox, and what invariably happened was a request would come in from a member and suddenly 2 replies would go out because myself and Nick handled it at the exact same time. That happened more often than you think. In 2009 we switched to this help desk system called Servers, which we hosted locally. It served us well over the years, but it actually, it was extreme future proof. It was a help desk that became 50 other things as well, and it just wasn't really comfortable to use anymore. So in 2013 we said, right, we need something new, and we started researching help desks. Has anyone done any help desk stuff? I felt like this. I really did. It was awful to go through help desk. Creating a demo account, sending in tickets. So the pain was so great, we just stuck with service. And then again, 2 years later, we said, right, we really need to do something. So I went on a new method of help desk research, which worked out quite well. And we looked at a lot of stuff. Freshdesk, I think, was, oh my god, I can't believe it's not Zendesk. Groove HQ, Zendesk, Kayako, Sub5, and there was a few more we looked at as well. I won't lie, all I knew of Zendesk before I started this was that it's this huge help desk thing and it's a massive company, so this was going to be, if Service was feature creep, Zendesk must be feature creep and massive. It wasn't. It was actually really simple, excellent API, supported Markdown, which is lovely when you're emailing config snippets and stuff like that. Nice UI, had all the apps, and it actually turned out to be the best, and it wasn't an extremely painful price either. So part of the process of doing this is we wanted to integrate help desk into IXP Manager. So we wanted our members to be able to see their past and current issues, open tickets and all that from within IXP Manager, without recreating Zendesk. So from IXP Manager's point of view, we had to be able to create customers, create users, find tickets, create tickets, and update and close tickets. Okay? So what we did is we listed what we needed to be able to do in terms of help desk API, and we created what Laravel calls contracts, but in programming terms are really, in object-oriented programming terms, is really just an interface, which means that when you implement an interface, you have to implement all the functions within it. So it's just the kind of things you'd expect: tickets, find all, organization, needs updating is a question, create, update, and same for contacts and users and so on. And what we did, if you're looking at the code, we created a Zendesk reference implementation, which is our one. We created a service provider, and if you need to add any new, say you want to go and do this with Cert5 or Freshdesk or something, it's just a couple of files you have to create, and then you open the pull request to us and we pull it all in. You'd effectively have to create this file, you'd have to change one line in here so that rather than having a Zendesk type of help desk, whatever you had, sort of 5 maybe. In Laravel, to actually access the help desk, it's just help desk equals @make IXP contracts help desk, and it'll do the right thing based on your configuration. So the configuration is config/help desk, and really, like for Zendesk, you're only talking about 4 things. The help desk backend, which is Zendesk. So this is where if you do something else, you want to stick in Server5 or Freshdesk or something else. The domain, which for us is INEX, some API access token, and then whoever's emailed that created that token. And now you have Zendesk help desk functionality. So there's command line tools that will create all the organizations and the users and keep them updated. So the only bit we haven't done is the front end bit where we list tickets and create tickets, but that's easy now because most of the hard work is kind of done. And that follows on then to how, what I said earlier on, we were talking about statistics backends, is where we're going to try and implement it for SFlow, peer-to-peer, MRTG log and MRTG ORD, using the exact same methodology. So if you had to use something else, you would just copy a particular file and just fill in the implementation. Installation is painful. It's not that painful. If you listen to us and install and go to LTS, it's really easy. If you want to use something awful like CentOS, it's going to be a nightmare. CentOS is they do real long-term stability. So if you look at PHP and CentOS, it's going to be 5.4 or something, right? Which is end of life in about 8 months' time. CentOS just doesn't stay current with what's required, and we will certainly require PHP 5.6 for Laravel, and possibly PHP 7 when it's released in a few months' time. So FreeBSD or Ubuntu are definitely the recommended places to install IXP Manager. When you do install it, the actual installation has gotten way easier with Laravel. When IXP Manager first started, this thing called Composer never existed. But Composer exists now. It's basically a package management system. It's like NPM for Node or whatever root has, I'm sure something similar. Where you can just do Composer, install some package, and off it comes. So when you git clone IXP Manager and you do Composer update, it will go off and get ZenFavorite1, Laravel, Smarty, Plates, Zendesk API, Doctrine, everything it needs will just come down and happen. And the same way we use Bar for the front end stuff like jQuery and Bootstrap and stuff like that. So I just show you one more thing I think, and then we'll wrap it up. Anyone here know what Vagrant is? Okay, a couple people. Vagrant, what they say is development environments made easy. So create and configure lightweight, reproducible, and portable development environments. What it is, as tool chains for development are getting bigger and bigger. You know, you need PHP, you need Composer, you need Bower, you need web server, you need MySQL. So just to start developing on a particular package can take hours of bootstrapping to get up and running. If you change your laptop or you want to do it somewhere else, it gets very difficult. So Vagrant kind of packages up the development environment so that you can start developing really, really fast. And what that means, to use IXP Manager with Vagrant, you need to install 2 things. You need to install Vagrant itself. You know, it exists for OS X, Linux, and Windows. I need to install a VirtualBox. Anyone heard of VirtualBox? Excellent. Okay. I think Vagrant will also work with Paradox, and it may work with other ones as well. But VirtualBox is kind of the one it's go-to virtualization. Then all you have to do is clone IXP Manager, cd into it, check out branch 4, Composer update, and Vagrant up. And the first time you do this, it'll take ages. It's going to download in Ubuntu ISO. Then it's going to start up Ubuntu, and it's going to do an apt-get update, upgrade. It's going to install all of the dependencies that you need for LAMP stack, Linux, Apache, MySQL, PHP. It's going to configure MySQL and PHP main. It's going to install Composer Bower. It'll configure public IXP Manager database with about 5 customers and interfaces and stuff like that. So a lot of sample data. It'll configure Apache and IXP Manager. And That's, by the way, the first time you do vagrant up, that happens. The next time you do it, it doesn't do that anymore. So the second time it's vagrant. Once it's complete, you can access IXP Manager at localhost 8088. You can log in with the admin password vagrant1. You can SSH into your new virtual machine vagrant SSH. The directory where you've cloned IXP Manager now exists on the virtual machine under /vagrant. MySQL is running on the machine, root and password, or you can just use installs PHP MyAdmin as well. And then just for managing it, you can log in, do a sudo shutdown.h to shut it down cleanly. You can suspend it, you can just force shut down it, you can bring it back up, and you can get status. So it makes it really easy, even if you wanted to just check out IXP Manager, see what it's like and you haven't done it before. You're really just talking about 6 steps, 5 steps even. And it's up and running on your local system. Let me just see if there's anything else before I go back to yeah, so this is actually the last page. I'll leave this one up when I'm finished. So just remember that V4 is a bridging version from Zen Framework 1 to Laravel. So at the same time, documentation is a little bit of a halfway house, right? We've been using the wiki, the GitHub wiki, up until now. It doesn't scale well for decent documentation. There's no cross-referencing. If you change your page name, you lose all your links. It's not really meant. So we started moving over to read the docs. I don't know if anyone has used that. It's actually really nice. And there's a source repository for IXP Manager documentation. I haven't ported over an awful lot. In fact, hardly anything. What I've got on the new one, read the docs, is the help desk stuff and some development stuff like all those vagrant instructions. So if you https://ixp-manager.readthedocs.org, you'll find all that vagrant information and stuff like that. The only other thing I was going to do was sort of a live demo of coding up a console command, but I think we'll skip that at this stage. Any questions or comments?
I have an interesting requirement, and I don't know whether it's supported, with MRTG graphs. How many years back have you
No. Log 10 years.
Yeah, MRTG is a bit, it's kind of messy because there's no way of reconfiguring it to use anything other than the defaults.
The problem is it rolls up data.
Yeah, I mean, if and when we have, new backends implemented like RRG and graphites and stuff like that. I mean, if you build this in an RRG backend, you can just say, well, if you want a month worth of samples at 5-minute intervals and then 10 years worth of samples for much longer. So, for example, the SFlow RRG files, default is to keep 10 years worth of data. But I think for MRTG it's quite a lot less. That's probably getting back into the question of how do you make a graph which shows the exchange growth over 5 or 10 years. We constantly get this harassed.
Yeah, I mean, like we have, like one of the girl who works in the office, I think one of her painful monthly jobs is to save copies of graphs. So she can have that.
Well, I mean, because of what we do in the region, we would like to see what 10 years looks like from now, peering in Africa 10 years from now.
Best advice today is record the data so that you can regenerate it. But once we have ORD, you can configure those parameters. Log files you can.
What we've done in INEX is just to save a copy of the output data, and we've saved that since 2008. So we have some data going back slightly patchy before that. And one day, when we get some time, we're actually just going to pull out those figures and make a lovely graph which shows it to the rocks.
Everybody else alright?
Brian, before it's not public right now, GitHub, right?
It is, yeah.
It is. I couldn't find it. Do you plan to release something else in 3.0?
Let's go there. Just drop the wiki. All the code is there.
Okay.
I don't know if GitHub is case sensitive or not, but that's correct.
Three. So you do not plan to release something else in under 3 point something?
No, no new
The-
features, just bug
The
fixes.
next release will be 4 point something.
Yeah, but if you go there and there's a little thing that says branches, if you drop down, you'll see V4.
Okay.
So V4 is an official release, we're running it, we're going to put it running on Run App, and then we build the documentation, and then we have an official release. In which case, the master branch will become V4. Currently, the master branch is 3.x.x. But the V4 branch is there on GitHub.
And second question, if I may, what do you use for billing or recording? Billing or recording self-serve configuration? Is there any integration between this system and the IXP Manager?
There's nothing in IC Manager for billing. That would be a whole other project. What INEX uses is, I think they use QuickBooks. I mean, there's other ones you can use. I think the place to get to is some cloud-based system with an API where you can just add in, you can port your database from IC Manager to the cloud-based accounting system, and just have your ports and add ports and invoices and stuff like that.
In your case, do you use the IXP Manager API to get some data? No.
It's handled manually.
I'm not sure if billing should be a part of the IXP Manager.
No, it shouldn't.
At least it should be. At least it should be able, to retrieve some data from there. And,
Yeah, no, I mean, if you're using an accounting package that does have some form of API, then it's something that can be easily scripted. But I don't foresee billing being part of IXP Manager. Not unless someone wants to come along with a truckload of money and something like that.
no, I'm not suggesting that it should. I'm just asking if it's easy to integrate data from.
I mean, at the end of the day, everything is in the MySQL database. So even if you don't want to use an API from MySQL, you could probably use the data from the JSON export schema to actually do your bit quite easily. But the database, the MySQL database is there in the background, so all the information is there anyway, the script around.
Is there an upgrade path from version 24?
Well, that's the reason why it's not in the master branch yet. What the upgrade path would probably be is to install it in parallel, and then run a few database schema changes, and then just switch Apache over to the autograde. So it'll be easy, but it won't be in place at the moment. Okay? Alright, well I'm around though for the next 3 days, so thank you very much.